Hello student, the question says two identical particles each of mass 0.5 kg are interconnected by a light spring of stiffness 100 Newton per meter. The time period of small oscillation is pi by 5 root 2, pi by 10 root 2, pi by 10 seconds. See, first let us see the simple way to solve the problem. The simplest way is reduced mass concept. We use the concept of reduced mass to solve this problem. What is this reduced mass is? We use this concept if external force is zero, if there is no, if F external is equals to zero, what, and both the bodies are moving simultaneously. Like example, if I compress this spring and move it, like if I compress this a little bit and I leave it, so both this will be moving in this way. So we can assume technically both would be moving simultaneously forward and backward, forward and backward. So in the way that I have represented here, in these kind of systems, if external force is zero, we can mathematically stop one of the body. This is not relative velocity concept. This is an entirely different concept called reduced mass system. If explained in this video, it would be a very lengthy one. I will create a separate video for reduced mass. So we mathematically stop one of them and we will redraw this entire diagram. So when you redraw this entire diagram, if you mathematically stop this, so it is like technically this mass gets disappeared. So there won't be any mass. So in place of this mass, we will assume something and we draw a new mass here. So we call this mass as M reduced. It won't be M. So we call this as MR. So this MR is generally represented with a symbol Q. This value would be equal to M1 M2 by M1 plus M2. So again, I will repeat, when you have two bodies and they are moving simultaneously and there is no external force acting on it, we will assume the surface is very smooth. There is no external force acting on it and they are connected by a spring and it is moving simultaneously. We can assume that this mass disappears and in place of this, there is a fixed body and we remove the other mass and in place of that, we will assume a reduced mass. This concept is called reduced mass system. How this system is equivalent to this system, to explain that the video would be very lengthy. We will discuss that in some other video. So we have reduced mass system U equals to M1 M2 by M1 plus M2. So based on that, in the previous question given, M1 equals to M2. Since M1 equals to M2, for the given case, we can write M into M divided by M plus M and it is equals to M. So it would be M square by 2M. So it is M by 2. And once we know reduced mass is M by 2, we know time period is 2 pi root M by K. Rather than using M by K, I'll use reduced mass by K. So I'll get 2 pi root M by 2K. So we will get this as our answer, 2 pi root M by root K. Let us substitute the values. So T equals to 2 pi root 0.5 and the value of K is given as 100. So if I take it, so basically we'll get 2 pi by 10 and root, this would be 1 by 2. So we'll get root 2 pi by 10. So root 2 pi by 10, basically pi by 5. We can write pi by 5 into 2. Here we have root 2. So I'll get pi by 5 root 2, which would be my option 1. There is another way to solve it using the concept of center of mass. Let us see the alternate method also. Alternate method is slightly lengthy. That is based on concept of center of mass. Since there is no external force acting on the body, if we have center of mass, we know center of mass is exactly here. Even though both of them are moving randomly, the center of mass of the system doesn't. Since the masses are equal, the center of mass will be at L by 2 distance from this end and it is at L by 2 distance from the other end. So from one end it is L by 2 distance, from another end it is L by 2 distance. Since center of mass is will not move due to internal forces, you can assume that there is a rod here that is fixed, and we have a spring of length L by 2 and a mass M is oscillating. And again another spring of mass L by 2, of length L by 2 and mass M oscillating here. And these two would be oscillating. The only difference is for the total spring, the spring constant is K. First, we have to find what is the spring constant for L by 2. We know in springs, K into L is equals to constant. If there is no change in other dimensions, we can say K into L is constant. So here we can find K into L equals to, let me call this as K1. So K1 into L by 2. Based on this, we will get the new stiffness of half of the spring would be 2K. Now time period of the system is nothing but time period of any one of them. So we will by time period equals to 2 pi root M by K1. So we'll get 2 pi root M by 2K. As you can see, even if you use reduced mass system, we got P equals to 2 pi root M by 2K, which on subsequently solving, we got option 1. Even if you use concept of center of mass and break down the system into two parts and solve it, we still got the same expression. What if it was M1 and M2? If it was M1 and M2, first we will get X1 center of mass and X2 center of mass, and we have to solve accordingly. Hope you understood how I have solved. Thank you.